Hello friends, just have a look at this code. In this code, I am asking the Arduino to wait for 5000 milliseconds. And according to you, what should be the output of this code? What should I get in the serial monitor? If your answer is 5000, then comment down below because you are partially correct. Because sometimes this code returns 4999, sometimes 5000, and even sometimes 5001 and 5002. Right? So why is this so? Actually, there is no problem in the Arduino board, but the reason is something different. So in this video, I'm going to explain the meaning of this millis function which we are using in this code and how it works, right? So before discussing this code, let me explain you some of the basics of the millis function. So here I have written some of the important points of the working of millis function. Let us discuss one by one. The first one is millis function uses timer 0 in the background to keep track of time. So timer 0 is one of the hardware timers used in the AVR type of microcontrollers, and Arduino Uno is one of them, right? So I have already discussed that what are the various types of hardware timers in my previous video. You can consider those videos for the understanding of the hardware timers, right? The second point is the timer 0 runs continuously and generates an interrupt every 1 millisecond. Now this is very important point, right? Interrupt every 1 millisecond. So I will discuss that what are the various types of interrupts in my upcoming video. For time being, you can consider that interrupt is a kind of signal that tells your microcontroller to stop the normal execution of the code which you have written in your Arduino IDE and quickly handle something that is very urgent, like external event, like your button press, like your uh, microcontroller getting some sensor value, right? So these kind of external event are very urgent that the microcontroller needs to be handled very urgently, right? So that comes under your interrupt, right? Now the third point is each time the interrupt is triggered and it increments the software counter variable, right? So each time when the interrupt is triggered by the hardware timer, this is timer 0. So this interrupt increments the software counter variable which is defined inside this millis function, right? This millis function. Okay. So that counter variable is defined in the millis function that gets increment when the timer triggers the interrupt. The fourth point is when we call the millis function, it simply returns the current value of that counter, right? Now this counter represents the number of milliseconds elapsed since the Arduino started or the boot. Okay. Now sixth and seventh point are very important. That is why I have written those in the capital letters, right? So the sixth point is the millis function only update once per millisecond tick. So as the timer 0 keeps on ticking, the millis function only update once per millisecond tick of the timer 0, right? And the seventh point is if we read in between the two ticks of the timer 0, then we will see the previous complete millisecond. Now what I mean by this seventh point, let us discuss here. Suppose the timer 0 is ticking like this, 1, 2, 3, 4, and like that up to 1000, right? And suppose next tick is 1001, right? Now, if we calling the millis function between 1000 and 1001 ticks, then the millis function would return only 1000 number of ticks. Why? Because we have called the millis function in between these two ticks and we have not yet reached the 1001th tick, right? So that is why a millis function returns only the previous complete millisecond. So the complete number of millisecond which has been elapsed are 1000, right? That is why millis function would return only 1000 and not 1001 because we have read the number of millisecond in between these two ticks and we have not reached yet up to the 1001th tick, right? So that is what I mean by the seventh point. Now let us discuss the entire sequence of the process of this code which we have written here. Okay. So the very first step is the powering on the Arduino, right? Then after that the timer 0 starts ticking, which is the hardware part. Then after that the core initialization of the Arduino begins. So all these steps, core initialization and the timer 0 starts. These are internal to the Arduino, okay? And we are not aware of that because automatically Arduino initializes these steps, okay? Then after these steps, the setup function begins running. That means our normal execution of the program starts running. And after that the millis start incrementing from 0, right? Now let us discuss that what happens during the core initialization and after the core initialization. So during core initialization these steps occurs. The first is the timer 0 gets configured. That means the timer 0 generates the interrupts after every 1 millisecond. Okay, then after that the millis function or the millis counter variable gets initialized to 0. So it's not the case that millis function starts to read after this setup function begins. No, the millis function, it starts before the setup function and gets initialized to 0. Okay, the third step is the the interrupt is enabled by this timer 0. And the fourth step is the configuration of all digital pins as the inputs by default. So when you power on the Arduino, all the digital pins on the Arduino board gets initialized as input pins by default. Okay, until and unless we define them as input or output. And the last step is the set up the analog to digital converter, which is used for the analog pins, right? Which are used in the PWM signal generation. Okay, so these steps happen in the core initialization. And what happens after the core initialization? The millis counter starts incrementing from 0. Okay, 1, 2, 3, 4 like that. And the setup function starts begins running. Okay, so these two steps happens after the core initialization of the Arduino, right? Now let us try to run the program which we have written here. So what we are doing in this code, basically we are initializing the serial communication between the computer and the Arduino board, and after that we are using a delay of 5000 millisecond, and after that we are calling the millis function whose data type is unsigned long, and we are printing the time we are getting from this millis function on the serial monitor. Now let us try to upload the code in the Arduino and let's see what output we will get. So in the serial monitor, after 5 seconds, you will notice that the time after 5 second delay will be coming out to be 4999, right? So you can see the time is coming out to 4999 and not 5000. So why is this? Why is this so? Because as the timer 0 keeps on ticking, like from 1, 2, 3, 4, like that up to 4999, 5000, 5001, like that. So basically what has happened with our code, our program resumed just after the completion of the next 1 millisecond interrupt by the timer 0. Okay, like I have already explained in this slide. Okay, this one. So the same thing is occurring in this program. So our program has resumed just before the completion of this 5000 millisecond, right? So we have called the millis in between the 4999 and 5000. That is why we are getting 4999 instead of 5000, because I have already told that the millis function will return the previous complete millisecond. So as a millis function called in these two ticks, that means 4999 and 5000. That is why the complete millisecond is 4999 and not 5000. Okay, and if you try to run this code in your system or the laptop, you can notice, or you can even notice that 5000 you will get in the serial monitor, or even 5001 is also possible sometimes, and it totally depends which Arduino you are using. Actually I am using the clone version of the original Arduino Uno. Okay, and it also depends on what is the precision of your timer 0, basically the hardware timer. Okay, so there are many factors which affect the timing of the millis and the timer 0, right? So I am using the clone version, and if you try to run this program on your laptop or the whatever system you want, you can notice that even if you get 5000 or even 5001, so there are many different possible output of this code. I am getting 4999, someone may get 5000 and you may get 5001, right? So that totally depends on what kind of Arduino you are using and what is the precision of the timer and the millis function, right? So let's end this video here. We will meet in the next video with the concept of the interrupts. So thanks for watching this video.